Hello and welcome to Hobby Paranormal. Today I'm going to explain the REM pod technology. I don't intend to tear this particular REM pod down because it's still intact, and opening them up would be rather destructive. But I have other ways in which I can examine the REM pod technology. Now this one here is the version 2.0, which also includes the temperature sensor, and it has a trend LED right there. Whoops, see, it's sensitive. It has the range button, and as I go and I step up, the range gets supposedly further away. But the operational theory is that this unit generates its own bubble of electromagnetic energy, and that if it's disturbed, anything that comes in and disturbs that field, that it would then alarm. So, and evidently that seems to be what happens when I bring my hand close to it. However, the tri-field meter is very sensitive, as I've shown in another episode, of magnetic and electrical fields. Now, first thing I'll do is I'll turn it on and let it settle down. And if I bring it close to the meter, you can see that there's really no elevated EMF field here. I have a K2 going in the background, and that too, we're setting off, but we're not having any EMF disturbance here. This also detects the electric field, or the E field, and again, there really isn't any appreciable fields around here. This is an active laboratory, and I have a lot of equipment around here, so the fact that it's not exactly zero isn't surprising, but if it were emanating any kind of field at all, magnetic or electric at all, I should see that field numbers go up. If I put this near some other technology, it clearly goes up. So let me demonstrate what I meant by if this meter gets near some technology. I have a power supply here, and it just goes off range. See what it does around electrical boxes. So sitting around my bench, it's about 0.3. I'm reading something. That must mean that there's some electrical systems here. Let me see if the oh, I just get it. These lights. Now let's go back here. Let's turn that REM pod back on again. Yeah, it's not generating anything. In fact, it's more sensitive to me moving around than most of my equipment's turned off in the lab. I do have a few things turned on, but it's almost reading zero there. It's reading what it was. The REM pod's turned off. Let me turn the REM pod on. There, it's sitting right, the tri-field meter is sitting directly on top of a REM pod that's turned on. Getting nothing. Absolutely nothing coming out of that REM pod. So it's not emanating any electromagnetic field. This would be able to detect it. It's not detecting anything. I must say that pretty much busts any idea that this REM pod emanates any sort of field whatsoever. So that's not how this sensor works at all. That's not how the REM pod technology works at all. I'm going to explain what actually the physics going on in the REM pod, how it actually works. And for that, let's go back to the beginning. REM pods didn't look like this. In the old days, in the version 1, it was basically this little kit right here. This is called a junior theremin. It's a musical instrument that was a kit. That kit was made by a company called Mad Lab. Mad Lab made these kits, and they were available. It only has 2 small integrated circuits and a piezo buzzer, that's the sound, and then some LEDs. 4 of them. So let's put a battery on this thing and see what happens. So the lights may light up differently, but that's all the programming that's done in the microprocessor. Oh my God, it goes squirrely. Wait 5 seconds, and it decides to reset itself. And once again, we can see that there's no field emanating here, even though I'm interrupting that field, supposedly. I only have like 0.2 or 0.3 milligauss in the electric field again. So what's going on? How is this detecting proximity? If it's not generating a field, how is it detecting my hand getting close to it? Well, the answer to that is capacity or capacitance. This wire that's acting as an aerial is one side of a capacitor, and my hand being grounded onto the floor or through whatever, it's acting as the other part of the capacity. So let's take a look at the signals that this device outputs. I think this is the best possible way of explaining how this is working. What we have here on the scope is the output of the 555, and it's producing what they call a square wave. Now when I bring my hand in the proximity to the antenna here, you can see what happens. Maybe let's try that again. Maybe that might be better. Although I'm not getting the trigger. Let me get the trigger level here. We want the positive edge of the trigger. Okay, so now let's try that again. So this is the Mad Lab's website. You can come to this page if you click on madlab.org/guide/theremin.html. And they have here simple instructions on how to use the Theremin. Instruction sheet link doesn't work, but that's the paper instructions that are in the kit. They have the schematic, which is the electrical diagram or the electronics diagram of the kit. And then they have the source code, which is the PIC processor microcontroller code. I will review both of them. You can see here that the schematic is separated into 3 different parts. The top part is the power supply, and there's the 9-volt battery, there's the power regulator, and the output is 5 volts. And this, you can see, powers the circuit. You can see +5 and +5. This other part's ground. Now the middle section here is the capacity sensing part. It's using a 555 in a slightly unusual way, but what they have here is the 555 component, and there's your aerial antenna. And the way it works is that traditionally there's a capacitor that goes to ground over on the side of the circuit, but they didn't provide a capacitor. The thing that is in the proximity of the aerial is the capacitor. And once that starts to have the capacity, the 555, and it will output a signal. This signal is the signal that we looked at on the scope. And you can see the signal will go into general purpose input number 2. This here is the PIC processor. This is a little microcontroller. And what you can see here is that the output here, and there are the 4 LEDs. Notice how they are back to back. This one's going forward with the arrow pointing forward. This one's backwards. That one's forward. That one's backwards. When you put the kit together, you'll notice that the LEDs are wired like that. There's also here the buttons. These are the push buttons, switch 1, S1, and switch 2, S2. And out there is the piezoelectric. And you'll see, and that's the speaker. So this is how the Junior Theremin works. Okay, this is the source code. And what we have here, of course, it says copyrighted by MadLab. And this code is likely what was modified to make the REM pod. So here we can see the code as it was written for the Theremin. And they have a few things here. I'll see if I can point out some stuff. Here's the recalibrate, equals for about 5 seconds. Some of the pitch, some of the period. I have measured 250 hertz for the beep. Let's see, what else do we have? This looks like a note table for the different tones. Since the REM pod doesn't have the notes, this has likely been removed from the code. These are the patterns for the LEDs when they multiplex them. That's what I've been able to figure out. Let's see, what else do we have? Of course, all of the code that's of interest is down in the main, which is down towards the bottom. Here we go. It says main entry point. After some initialization, they go into what they call the main loop. The main loop is then doing something with the pulsing and everything. You could say here, if it's decrement, some sort of counter, and then if it's 0, then go to recal. And so it says if it's not, then it's going to go over here. So it's going to skip this part of it. Otherwise, it's going to go and it's going to recalibrate. So every 5 seconds, it'll recalibrate itself. What else do we see here? The slide mode is the one where is the REM pod version of it, because that way it allows you to not have discrete notes. And that's what they're doing here. They would have different notes that they would play if you're in the discrete note mode. But the entire code is written in assembly language. Okay, well, that's all I have to say about the source code. If this is an interest of yours, please like and subscribe to the channel. It shows me that you like this content and want to see more of it. Thanks for watching.